Hello everyone, welcome back. I hope you are all doing great. So let's start with a very simple tutorial with a utility buildup using a PyCryptodom. And the purpose of this utility is something to encrypt as well as decrypt any file content that you are interested. So let's see what exactly we are going to do with this tutorial or maybe the utilities. It is a PyCryptodom library that will be offering something called AES, which is nothing but called Advanced Encryption Standards, and it has a fixed data block size of 16 bytes, and it takes the keys. This key is basically to lock the file content or encrypt the file content, and the length of this key is something called 128, 192, or max 256 bits long. It can support. So let's see how the code it works. Very simple code over here, as you can see. So first we'll be importing this AES out of this crypto library, and then it starts with a static key which will be used to lock the file, not a lock, rather encrypting the file. And now it uses a constructor of this AES using the same key, and a mode it calls EAX, and with this mode it generates that instance of the cipher object. Now what is this mode? So if you just quickly check in wiki, it says it's something called encrypt, then authenticate, and then translate. So it's a mode of operation for cryptographic block ciphers. Now what the behind the scene kind of algorithm that it works is called AEAD, which is nothing but authenticated encryption with associated data. A lot of big things. What exactly it does means, like, if I lock the file content with certain key phrase, then if I try to decrypt the content with another key, it will fail, and it will not decrypting the content, or it will not be corrupting the content. So that probably the reason I'll be using this EAX mode in our POC or in our utility development. So once it generates the cipher object, next piece is simply just to run this encrypt and digest, and with the data. Data is nothing but the file content, and our cipher text is generated. This text is nothing but the encrypted content of this particular data. So that is overall the encryption process. It's pretty simple, right? Now during the decryption process, how it works, it says like, hey, I need the same key, and the mode of operation should be, of course, EAX. But now I need another parameter, and that is called nuns, which we will be able to receive it during our encryption process. Okay, so you have to store somewhere this nuns, because that time that nuns will be using to decrypt the same file. So obviously it's needed. And now simply decrypt and passing the same cipher text, and it will return my plain text, which is my original content. Very simple thing that we are going to achieve in our utility buildup. And I'll be using my VS Code and console log input to perform this utility. So let's head over to our development now. So now we are in my VS Code, and let's start with the terminal. And what are the dependent modules or libraries that we'll be using over here? For that, we'll need a virtual environment, and under which I'll be installing all my dependent modules. So that will be easy, so that it will not conflict with any other versions installed globally in my computer. So now to start with, I will run the command called python -m virtual environment, and the folder which will be created is also virtual environment. So it will take little time. So it's done. So let's now activate. To activate this one, what we have to do, go to scripts, and this is the batch file which you need to run. So I'm on Windows, so what I'll do, I'll just get into that scripts and then run activate. So if you're in Mac, then you have to write source then activate. Okay, so as in Windows, so I'll just run activate, and ideally it should activate by this time. So let's close once again, and again it should, yeah, now it's auto set to virtual environment. So that is all we need it. So now let's collapse it, and now what are the dependent ones that we need? So let's run the command pip freeze, and it's empty because we haven't yet installed anything. So we need pip free install PyCryptodom and PyChuck. So these two things I'll just install. I think I made a mistake. It should be PyCryptodom. So once it's installed, then we can recheck our pip freeze, and then we'll see it's all installed with the latest version. So now let's run once again the command called piptrace, and it's now showing this is the version for PyChalk and PyCryptodom, these two we have installed. Cool. So next is let's create a script file which I want to run for my utility, calling it script.py. Now to start with, let's add the modules which we'll be using in this particular utilities. Here is my AES, which is an advanced encryption standards imported from the script library. I'll be using hashleaf because whatever the user will enter as the key, as a string kind of, that I'll convert into SHA-256 binaries. And finally, I'll be using this chalk for console log coloring. So that's overall the dependent models and libraries that I need. Now next would be that the user will enter the application will prompt for user to enter the password. So let's put those logics first. So the logic is very simple. I'll just say like, hey, enter the key values in the console and confirm the key. If the password and this confirm password both are same, then I'll do certain things. Currently I have put as a break, that's okay. And finally, if we'll validate and find this is incorrect, then I'll just give a mismatch console outcome. That's a simple thing that I have done. Now the overall encryption and decryption logic, I want to put it under a particular class. So let's build this class now. So the class name, I'm just calling it as my encryptor with an instant, or rather the constructor as dunder in it, which will take the user tree as an input, and it will just take it into this self instance variable. Fine. So I need a couple of few more methods so to work on. So to save some time, I'm not typing all the way, but I'll explain what exactly we're doing. So two methods I've created. One is encrypt all files, and the other one is the decrypt all files. Now the first method will traverse and get all the files within this particular project directory, starting from the root. And this method, definitely we have to create it, and once we get all the valid directories and files, we'll just loop through those and we'll just individually encrypt each file through this particular method. And this method also we need to create it. The same logic, but this time it's a different flag I'm passing as a D, and also we'll be just using each file to decrypt the content. So this is two primary methods that we need to start with. So let's build it up now, the get files method. So get file methods, let's put it over here before this encryption, and let's see what it does. So first it will take the current directory and the concerned path through which it will start to traverse into the different subdirectories and directories, etc. And then I have just added one exclude kind of a list, and this will contain VNV, which is nothing my virtual environment, as well as the VS Code. If someone does a configuration settings for the debugging this project, that VS Code will automatically create this particular folder called .vs Code. So this also I have just added because we definitely don't need to encrypt those content. So we have to be really sure those files we don't damage it by this process. So now this exclude will ensure this particular two folders will not be in consideration for encryption and decryption process. Next, I have just set it up variable as a list, call it directories, and that will append different directories and files inside this particular list. So this is the particular line of iteration process where it will just walk through the current directory path, which will just have determined. And I'm saying is top-down approach should be true, means from the root it will start navigating all the directories and folders, subfolders, and it will just get those information under these particular three variables. So here the subdirectories will contain the immediate directories that it will traverse in the next loop or iteration. So whether that directory is to consider or not, we have to just validate. This is kind of a list comprehension I'm just using. I'll just look through these subdirectories and I'll just validate if that directory is not in our exclude listing. So that means that is a directory that is safe to be encrypted or rather to be considered. So that way this subdirectories list will be having those specific valid directories that we should, rather the application should traverse through. So once I have this information, what next is to, for the current loop, right, you just loop through this all the files, and depending on the mode, because two modes we have passed from these methods, you see this E I'm passing while it is an encryption process, and D I'm passing when it's a decryption process. So this mode I'm just considering, if it's an encryption, I have to ensure that I'll not encrypt any Python files or maybe any encrypted files already, which already encrypted. I should not re-encrypt it. And this extension, I'll just ensure that when I'm generating that encrypted file, the extension should be with .enc. So that's the way I'm just using a slicing, and I'm just ensuring that enc and py, those particular files, I'll not be considering for encryption. So rest all the files should be either encrypted or decrypted. So that is the reason I just put this little validation. And finally, I'm just considering those directories if this matches these conditions. And similarly, during decryption operation, I'll just ensure only the encrypted files should be decrypted, no any other files to be considered. And finally, I'm just returning those list of files and directories out of this return parameter, return syntax. So that's my all files or get all files a particular method does, and it's all good. So once I get those directories as a return, definitely next I'm just looping through all those files, and I'll be creating two new methods now. One is an encrypt file, and there is a decrypt file. And in each loop pass, I'll just pass on that particular file details so that that file can name or path can be considered within this encrypt and decrypt file for the following process. So of course, the next journey should be to create these two methods, right? One is an encrypt and the other one is the decrypt file. So let's first go for the decrypt file method, and let's put it just before that. Within, okay. So this is my decrypt file. I'll explain what it is doing. Let's collapse for the time being. We need one more method, and that is our encrypt file. So let's copy this code from my other program. Let me pass it here. So this is my encrypt file and this is my decrypt file. So let's understand what it does. So as I've seen, that encrypt file means it'll just take the file path and file details, not the file content, only the file path and the file name. So this all I'll just pass it as a parameter to this encrypt file. So it will take file name. So let's get into this my encrypt file, and it is taking the same file name as an argument, as a parameter rather. So now it is opening the file. Let's open this file in read binary mode and read the content, and I'm calling it as a plain text. So as you have seen now to encrypt this one, we just have to call another method called encrypt. We haven't yet created this one, but we'll be just calling a new method called encrypt, which will take the plain text, which is nothing but the content or data of that file, and I'll just destructure or return these three things out of this method, which is a ciphertext. This is nothing but the content in encrypted mode, the tags and the cipher. Three things will just basically take out from this method. We'll create soon this encrypt method, and once we have this, so what we are going to do, we'll be creating a new file with the extension as .enc, and this is a list comprehension again, and we're telling like, hey, well, I'm creating it, make sure that you take the nonce, the tag and ciphertext all together and put it create a new file which will contain everything inside, because we'll need this nonce and tags both during our decryption process along with the ciphertext. So obviously three things I want to keep it within my same file itself, which will which this particular methods is regenerating as a new file of extension .enc. and then I'm just removing the original file, because no more I need the original file, because that obviously the purpose. We have to remove that original file and we'll recreate a new file of extension.enc, which will not only contain the original, kind of an encrypted version of the original content, which is this one. Along with it will take nonce and tags also a part of the content, so that that can be used later on for decryption activities. So I hope this pretty simple thing, this encrypt file method, let's collapse it and let's also explain the decrypt file now. So during decryption means, again, the file name which I want to decrypt, I'll read it as a binary mode. And again, this particular length I'll be using with kind of to extract this nonce tag, which we put it as a content during our encrypted file creation. So that we just again read it back and put it under the three variables, ciphertext, tag, and nonce, which we'll be using now to decrypt. So obviously now we'll be running, or rather calling, a new method called decrypt, which we have to create now, and we'll be passing this particular ciphertext, nonce, and tag again back. And the content which we'll get is obviously now the decrypted content. Now if we are passing kind of a wrong value or wrong nonce or incorrect tagging, then obviously this will fail and it will not be returning any content. So we are saying like it is incorrect. In that case, I'll just exit it out if it's none, and otherwise I'll just create a file and in a writing mode now, and now we'll be removing this .enc extension, and I'll get that file name now, which is the original file name, whatever the original file name with the extension was. I'll now get over there with this file, and that I'll just create it with the same decrypted content. And now this file name I'll removing means I'm just removing the encrypted file in this case, because my decryption is successful, and now I'm just removing the encrypted file, which makes sense. So what now, two things we have to create. One is a decrypt method that we have to create. Similar way we have to create the encrypt method. So let's create these two methods now. So I'll just take it from my other program just to save time and not to type all the things. Okay, so encrypt method is now, if I just explain what encrypt method is taking, it is taking the actual data for encryption. So this is what the data, and it's an instance method, that's why self I have put. Now here this self contains the keys, because these keys we can extract from the original constructor method, because already we'll be using this constructor method to pass my user input. So this key will be grabbing from this self variable, and we know that we'll be using this mode EAX, right, for authenticated encryption mode. And now we'll be creating a cipher object, because this is nothing but an instance generation of this AES model. And once we have the cipher object, now we'll call this method called encrypt and digest, and we'll pass the data which we want to encrypt. And if it is successful, all things are encryption is fine, then we'll get those ciphertext and tag, and that will just pass back as a return, because those will be using, just now I have explained, those three things will be using for decryption. So this encrypt method should return those critical information. So what next? So of course we now need one more method to create, and that is our decrypt method. So let's build that two as well. So now this decrypt method will be called from this decrypt files method. You see, this is the one it will be called from, and it takes ciphertext, means the encrypted content, as well as certain other values like nonce and tags as an input parameter, right, that is going to pass it. So the same information I'll be getting over here, ciphertext, nonce, and tag, and inside that again I'm just creating a new instance of my cipher object, but this time I'm passing additional parameters called nonce, which we have received over here as an input, and will not call the decrypt method, because we have seen here it's just using a decrypt method, right? but we'll be using another method called decrypt and verify, and we'll be passing the encrypted text, which is nothing but a ciphertext, and the tag which we generated during encryption process. So, and this particular piece of code I'm just capturing under a try catch block, so that if any error happens during decryption, because if my key I'm passing is an incorrect or invalid key, then this process will fail, and that time we can pass it as like an error saying like a incorrect or missing or message corrupted. So we can put a little chalk over here, and we can put a red mark kind of, so it looks kind of an error. So this overall my decryption process is done. So I think all good. Of course, now one thing is missing here, and that is the content which we received at the first time as an input. This password we have received. So we have to now call our methods and the constructor, right, which will just ensure that it is getting that password. So what it does, I'll be just calling this particular line of code and saying like, hey, call this my class, which is my my encrypted class, and use the same password, but this password will be converted into SHA-256, so using this method which is not yet created. So let's create this method now. So this is the simple method that I want to create. Let's put it above this while loop. So I'm using saying like, hey, this password I just encode into binary form, and this key I'll just return it back. So this key I'll just pass it into my constructor, and that will be feeding up my dunder init method with self key. Simple. So once this is done, what next? We'll be writing up a few more methods to call those things. So let's say I just need a few more lines of code after this while loop is done, saying like, hey, what are the different option and choice that I want to go with. So I'll say like, yeah, clear method is not yet done, so I'll create it soon. Let's create this clear method also, what I wanted to create. So just kind of a lambda function that I'll just create now, just a console clearance. So what I'm doing, like, hey, I'm saying like, once the input, the different options I'm giving, once user gives the correct password and my instance creation is successful with my encrypted class, then I'm just giving an option for the user to choose from, and I'm just calling different methods based on which options they want to go with. So my coding is all set. So why don't we test it now? So let's test this code now. So for the testing purpose, I added a couple of files. One is the hello text, which is under my text files, and execution flow png, which is an image under the my images. So kind of a subdirectories or nested kind of a folders. Now to start with, what I'll do, I'll just run the script files which you have created. So the key I need to pass, let's say put abc123, confirm the same key. Now it offers an option like which file I want to decrypt, or which option I should go with. So I should go with the 3 because I want to do all files together, so that way I can test all my logics. So I should go by 3, and it says now it all changed to .enc and .enc ended with png. So if I just click on these files, it's all encrypted, and now it is not supported to be displayed. Now we can now close it by keeping a 5. If I can press 5, I can exit it, or even I can press 4. Then on the same session, it will use the same earlier key, and then it will be decrypting it as a mask way, mask processing, and it's back to now hello world and that image execution. Okay, that is what we needed. Let's do little validations now. So come out of that, and let's do one more round, and this time again pass any value like gg123, some sort of a passcode. Again, let's encrypt this both the files, And as you can see that now it is not considering any VNV folders as well as any script folders is not encrypting, but only rest of the things it's considered. And even in nested way, all the folders and files it's just considering for encryption. And now let's exit from this particular process and now re-enter to this application and give a different key. Let's say G8123. Okay. Obviously it's an invalid key, so my intention is now to decrypt with this invalid key. So if we just go for a third option, means it's already encrypted these two files, so obviously it will not be encrypting anything. That is, we already validated and protected those scenario. But now we need to do a validation, like this incorrect key, because the next password we have just entered is not the correct one. If we just place 4, yeah, it says that key incorrect or message corrupted. That is the message we all entered, as you can recall, with our validation process during decryption methods. We just all ensured this one, that same key incorrect message corrupted. So that is the error message is coming up. So that way we are safe, like we are not mistakenly accepting an invalid key and trying to decrypt this file, which will be really damaging my content permanently. So now to start with, or maybe properly decrypting, so let's put the actual passcode. Now click on 4. Voila, you see now it's all back to the original content. That's all. I hope this discussion was helpful to you, and thanks for watching. And so if you like my work, drop a like and share and subscribe my channel if you're coming to my channel for the first time, of course. And don't forget to hit the bell icon, because it will intimate you the moment I upload a new content to my channel. And stay tuned for the next episode.